Hi, hello. Welcome to Meki Teki. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement for creating these kinds of technical videos in the public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for creating me a spark of creating more these kinds of videos in the public domain. I would like to thank Almighty for my good health and broad mind, and I would like to thank my friends, followers, my dear students and subscribers for their continuous support. Now, today's topic of interest is frames. Before seeing the frames, we have to know the difference between trusses and frames. Trusses are the rigid structure composed of number of straight members which are pin joined to each other, where frames is not like that. In the pin joint of the trusses, it does not transmit motion, whereas in the frame, the structure member consists of arbitrarily oriented member of beams or connected by means of a rigidly or by the pin joint. This pin joint won't transmit it does transmit motion. So in the trusses does not transmit motion, where the frames can be rigidly mounted or been welded together, which is called as a frames. If you see in a house in the ancient day houses, and nowadays those houses are rebuilt by using frames which the steel rods are welded. That is why it is called as a frames, where I would like to give certain differences between trusses as well as the frames, where the first difference is the trusses, the joints are in pin type, where in the frames the joints are a rigid or a welded types. The truss can rotate about the pin joint freely. The trusses can rotate the pin joint freely, but frames does not rotate. And the pin joint don't does not transverse moment, whereas the frames it does transmit moment. Trusses are designed to bear tensile as well as the compressive load only. Please make a note, the trusses are designed for carrying tensile and compressive load only, whereas frames can withstand both axial loads as well as the bending loads, axial as well as the transverse loads, that is shear and tensile and compression. That is the meaning. In trusses, only nodal forces can be allowed, there is no moments can be allowed. Whereas in the frames, it is a point loaded or uniformly distributed or uniformly varying, even the moments can apply in the frames. For your information, our beams and columns are the types of frames. Since they can allow both point load, uniformly distributed load, uniformly varying load, as well as the moments. So, with this background, I would like to go into the frames. So, before seeing the frames, we want to know what is meant by a chain. Because when the frame, when the frame, if degree of freedom is more than zero, if the degree of freedom is more than zero, it is called as a mechanism. Generally, chain is a type of a mechanism. So, with this information, the equation from Kutzbach, we are going to derive the types of a chain first. That is J plus H by 2, which is equal to 3 by 2 L minus 2. So this is the equation which we are going to consider, where j is the number of joints, h is the number of higher pair, l is number of lower pair. If we split it, j plus h is a left hand side and 3 by 2l minus 2 is the right hand side. When LHS is equal to RHS, when right hand side is equal to left hand side, that is called as a constrained chain. So this is called as a constrained chain. When LHS is equal to RHS, it will become constrained chain. When LHS is more than RHS, then it is said to be a locked chain. And where the LHS is less than RHS, it is to be an unconstrained chain. The constrained as well as the locked chain is very good for transmitting motion, whereas the unconstrained chain won't transmit the motion. So basically, this equation is derived from the equation like Kutzbach equation. This is the shortest form of the Kutzbach equation, where two members are good in defining the degree of freedom, that is Kutzbach as well as the Grubler. Kutzbach and Grubler, where as per the Kutzbach equation, the degree of freedom is equal to 3 into n minus 1 minus 2j minus h, where h is the higher pair, j is the joint, n is the number of link. Whereas in the Grubler, he won't consider the higher pair. So Grubler criterion is derived from the Kutzbach criterion. Therefore, the Grubler criterion will becomes dyf is equal to 3 into n minus 1 minus 2j. Here, we want to understand two things. In a structure, for a structure, the degree of freedom is always 0. If the degree of freedom is equal to minus 1, this is called as an indeterminate or a superstructure. Therefore, we have to understand that the degree of freedom should not be less than 0. If in the frame cases, if the degree of freedom which is equal to 0 is called frames, and degree of freedom is less than or more than 0, it is called as an imperfect frames. When the degree of freedom is equal to 0, it is called as a perfect frame. When the degree of freedom is not equal to that, it is called as an, when degree of freedom is less than 0, it is called as a redundant, and more than 0, it is called as a mechanism. Here we want to remember certain points, that is, we have an inertia frame, a rigid body as well as the free body diagram. The inertial frame, it is origin at the center of mass of a body. So that is called as an inertial frame. If a frame is fixed at the center of the mass of the body, then it is called as an inertial frame. The rigid body won't deform. That is why the deformation is negligible and has a continuous distribution of masses. And the rigid body is having continuous distribution of masses, and it does not affected by an external force. That is very very important. Next, which is the free body, it is isolated from its surroundings and external forces, which is called as a free body. And where the frames are divided into two types, one is perfect frame and another one is imperfect frame. In imperfect frame, we can divide it into two types. One is deficient and another one is redundant. So, these types of frames are postulated using an equation, that is 2j minus 3 is equal to m. This, if any m, this is m, where j is the joints, where m is the members. If 2j minus 3 is equal to number of members, that is said to be a perfect frame. If it is less than or more than, it is said to be an imperfect frame which is not equal to m. When 2j minus 3 is not equal to m, it is said to be an imperfect frame. Where if it is a deficient frame, if members are less, if members are less and 2j minus 3 is more than m, it is said to be a deficient. If 2j minus 3 is less than m, if members is more, that is called redundant frame. In perfect frame, the points are to be hinged and smooth surface creates reaction and motion. This we have to understand. And the methods of substitution which is equal to needed in redundant frame. Methods of substitution is needed in redundant frame. I would like to give certain example of this perfect and imperfect frames. We consider a triangle. So this is a perfect frame. I am going to say this is my joints. I have 1, 2 and 3 joints, and this is have a members of A, B and C. Here the members is equal to 3 and joints is equal to 3. If we substitute in the equation 2j minus 3 which is equal to m, where j is equal to 3 and m is equal to 3. 2 with 3 are 6, 6 minus 3 which is equal to 3 is equal to 3. Therefore, this is said to be an perfect frame. So similarly, the imperfect frame, which I would like to give an example, say this is my frame. So here I am having a joints of 1, 2, 3, 4, 5. So I am having 5 joints where A, B, C, D, E, F, G. So 1, 2, 3, 4, 5, 6, 7, 8. So members are 8, joints is equal to 5. Therefore 2j minus 3 which is equal to 8. So if we substitute in the j, if j is 5, so 2 into 5 10. 10 minus 3 which is 7. 7 is not equal to 8. Therefore it is not a perfect frame. It is an imperfect frame. When clearly it is said to be a deficient frame too. If this is 2j minus 3 value, this is less than members, therefore sorry, it is an redundant frame. Therefore members are more, therefore it is called as a redundant frame. Like this, the frames are categorized. Next, I would like to give some glimpse in lift. Where if the lift is in upward motion, if the lift is in upward motion, the F, we know that F is equal to, as per Newton's second law, F is equal to, sorry, F is equal to mass into acceleration. If the lift is going in upward direction, then F is equal to m into A plus G. So this is an upward direction. Where the lift is moving in a downward direction, F is equal to m into A minus G. Therefore, it is in a downward direction. So this we have to understand. In lift is moving upward direction, it is against gravity. Therefore, the gravity is in the addition. If the lift is moving in the downward direction, it is free falling body like kind of a thing. Therefore, gravity is getting negative. And for an example, if a person is moving in a lift, when the lift is moving and with a certain uniform speed of the upward motion, the body will loses the weight. It can feel on losing its weight. Whereas in downward direction, when body is gaining the weight. So this is our understanding. Here, the in the lift, the tension in the cable is more important. The tension in the supporting cable at the lift is more than the lift moving upward with uniform velocity. So, this we have to understand. And moreover, the tension is more at the fixed end. The tension is more at the fixed end. For an example, in the lift, they are using in a box, the carrying box, load carrying box in one side, and another side we are using equivalent masses. The purpose of equivalent mass is used to make the balance between the mass to be lifted and the fixed mass, where the masses are m1 and m2 tied in the thread like kind of a thing. At the acceleration of the string, both are same. The load carrying on the string is half at the each side. Therefore, if say this is my lift and this is my dead weights, if, if loads are acting here, the both will take equally at the each side. So this is our understanding about the lift. So with this information, I would like to close my today's topic, frames. If you have any doubts, please let me know in the comment section. I will put a definitely I will put another video on this doubts. So with this, I'm going to closing the session. Thank you all.